So let us talk about the physical structure of an E-MOSFET. As you can see here, you have the P-type substrate extending all the way to the insulated silicon oxide layer or glass, a very thin layer of glass. So your gate is insulated from your P-type substrate. The drain and the source is placed or situated at the N-type semiconductor material. And as you can see here, there is no channel in between, so there is no current flow. So let us talk about the operation. Let's say I have an N-channel E-MOSFET. I apply voltage here. For example, my VDS here is 8 volt. So this is 8 volt. 8 volt. And my threshold gate to source terminal is 4 volts. What does that mean? So I will just put it here, VGS threshold is equal to 4 volt. Okay, and this is the maximum limit that my gate voltage can handle. Okay, plus minus 20 volts. So if I apply more than 20 volt here, I will destroy my gate terminal. Let me just put it here, VGS plus minus 20. So it means that you should not exceed 20 volt at the gate. So this is my gate voltage, positive. So from 0 volt, for example. Since this is 0, I don't have any source here. So I don't have any channel. So I don't have any current flow. Okay, so my transistor, okay, MOSFET is also a transistor. So my MOSFET, my transistor is off. Now if I increase my gate voltage here, I increase this to 1 volt, 2 volt, 3 volt, for example. Okay, and so this is now positive, this is now positive. Now if this is positive, the electrons will be attracted to the gate and thus forming a channel. But since 3 volt is less than my threshold gate to source voltage level, so it is not strong enough to attract the electrons here. Only at greater than 4 volts, then it is strong enough to attract the electrons. Let's say, for example, at 6 volt, it is now strong enough to attract the electrons and thus forming a channel. So if a positive voltage, if my gate voltage here is greater than my threshold gate voltage here, it will attract free electrons toward the P region. This is the P region, so electrons is attracted here. So the electrons is attracted here. Okay, so at VG greater than 4 volts, I will have a channel, and now current can flow through the transistor. Okay, because now I have a channel here. It means that at greater than 4 volts, my transistor is on and current can flow through. If I increase VG from 6 to, for example, 8 volt, my positive charge will be stronger and stronger if I increase my gate voltage. And therefore, I will attract more and more electrons. So there will be more and more electrons. There will be more and more conductivity. More drain current can flow through. Therefore, the conductivity of the channels increase and more current can flow. You can keep on increasing the gate voltage, but do not exceed the 20 volt maximum rating. And that concludes our tutorial.